Hey everyone, welcome to This Explainer. Today, we're exploring a truly fascinating intersection, the high-stakes world of international football, and, believe it or not, the precise, rule-bound world of electrical engineering. I know, it might sound like a totally unlikely pairing right off the bat, but by the end of this, you're gonna see the beautiful game in a completely different light. So, let's turn the power on.
Have you ever found yourself wondering why football fans are absolutely convinced that FIFA plays favorites? I mean, it's a conversation you hear in living rooms, stadiums, and comment sections literally all over the world. People are constantly arguing that certain teams just get special treatment. You know the drill. Fans will swear that Argentina gets all the calls, or they'll point a finger at another massive football powerhouse, claiming the whole system is rigged for them. It's a very emotional, very human reaction to the sport. But what if we took all that emotion out of it? What if we looked at FIFA not as some subjective, biased sports organization, but as a rigid, objective system? Specifically, what if we looked at it like a giant electrical power grid?
Okay, let's dive into this. Imagine FIFA as the world's largest electrical grid. Just think about a massive national power grid for a second. It really only has one singular job, right? Delivering electricity to millions of individual homes. It doesn't sit there and decide which home deserves the power more. It just delivers it. Well, FIFA operates the exact same way. It delivers one strict, universal set of rules to every single national team on the planet. The grid doesn't care if you live in a massive mansion or a tiny studio apartment. It just provides the power. And in that same exact way, this overarching infrastructure of football exists simply to supply the framework of the game across the globe.
The implications of this are just fascinating. Because on one hand, we've got incredibly diverse national teams. You've got Argentina, Spain, Brazil, Japan. They all have completely different cultures, entirely different styles of play, rich, unique histories. And yet, every single one of these teams is connected to the exact same energy source. They all receive the exact same voltage. The baseline power being supplied to Argentina is technically speaking identical to the baseline power being supplied to Japan. That connection to the source is entirely uniform across the whole globe.
Okay, let's keep building on this and look at the officials on the pitch. Think of the referee as a circuit breaker. Now, if you know anything about that circuit breaker panel in your house, you know it absolutely doesn't choose which appliance it likes best. It doesn't have a bias towards your refrigerator over your television. It just sits there, quietly monitoring the flow, and the second it detects a fault or an overload, boom, it disconnects the circuit. It's purely functional. Similarly, the referee's job is to impartially stop dangerous fouls and enforce the rules. When a fault occurs on the pitch, the referee basically trips the breaker to keep the entire system safe and functioning properly. But what happens when the situation is just incredibly complex? You know, when the naked eye isn't enough to figure out if a fault actually occurred? Well, enter VAR, the Video Assistant Referee. For our analogy, imagine VAR as a digital multimeter. When a ref isn't completely sure about a decision, maybe it's a potential penalty or a super tight offside call, they don't just guess. VAR steps in to measure the situation again. It acts exactly like an electrical engineer who pulls out a highly sensitive digital multimeter to precisely check the voltage or current before making a final call on the health of the circuit. It's just a secondary, precise measurement tool to make sure the grid is operating exactly as it should be. And this brilliantly illustrates the foundation of it all, the standards. In engineering, we have global electrical standards. These are the mandatory technical guidelines that every single component connected to the grid absolutely has to follow to function properly. I mean, if a wire or a plug doesn't meet these standards, the whole system fails. In our football analogy, these standards are the laws of the game. Every single team must follow the exact same pitch dimensions, and everyone is subject to the exact same offside rules. These are the non-negotiable technical guidelines of the sport. You literally cannot plug into the FIFA grid unless you are fully compliant with these standards. So, the crucial point is, if the rules are identical for everyone, if the referee is just an impartial circuit breaker, and if every single team is receiving the exact same voltage from the grid, why in the world do some teams win so much more often than others? This is the pivotal question that bridges the gap between the theoretical rules of the game and the actual real-world performance output we see on the pitch. Think about it. If the power supply is entirely equal, the inequality in the results must be coming from somewhere else entirely. Now, what's really interesting about this slide is how it answers that exact question through pure engineering. In electrical engineering, if you take two motors and supply them with the exact same voltage, they don't necessarily do the exact same amount of work. The better designed motor, the one with less friction, better wiring, superior engineering, is naturally going to perform much more efficiently. It converts that baseline voltage into way more raw power. And the exact same principle applies to football. A winning football team is simply a better designed electrical motor. They are taking the uniform voltage provided by the FIFA grid and converting it into output far more effectively than their opponents.
So what exactly makes a football team a better designed motor? Well, it really comes down to specific internal components that convert that raw energy into actual victories. First off, you have better teamwork. This is basically how smoothly the internal components of the motor interact without causing unnecessary friction. Second is smarter tactics. That's the engineering design that actually maximizes the current. Third, stronger preparation. This is all about ensuring the motor is perfectly maintained and ready for a heavy load before the machine is even turned on. And finally, taking chances when they matter most. This is the team's ability to handle sudden surges in pressure without breaking down. These are the internal mechanisms that turn equal voltage into superior performance.
Bringing all of these concepts together, we land right on our core thesis. Receiving the exact same power does not guarantee the same performance. So, does every team receive the same voltage from FIFA? According to the rigid architecture of the rules, yes, technically they do. But just like in electrical engineering, receiving that same baseline power is really only half the equation. The real difference, the actual reason why certain teams lift trophies while others are sent packing early, lies entirely in how efficiently each individual team converts that raw equal energy into tangible results on the pitch.
Which leaves us with this final, somewhat provocative thought. We've built a pretty strong case today for viewing the beautiful game through the lens of circuits, voltage, and motors. But what do you think? Does football truly work like an electrical grid, or is there another analogy out there that explains the mechanics of the game even better? I really want you to think about this one and definitely leave your opinion in the comments below. We absolutely love seeing how you all process these concepts. And hey, if you enjoyed having football explained through the logical structure of electrical engineering, make sure to subscribe to TechnoSapiens for more explainers like this one. Thanks so much for learning with us today.